Hello, today we're going to learn how to find all the roots of a polynomial function. And to do that, we have a theorem called the fundamental theorem of algebra. And it states that an nth degree polynomial has n roots, including multiple and complex roots. So it tells us exactly how many roots each polynomial will give. Well, we have a fourth degree polynomial here. So basically that tells us that we will have 4 roots when all is said and done. Now, it also says it includes multiple and complex roots. We learned what complex roots were yesterday, but multiple roots. Well, what does the word say? Multiple. Multiple roots means any root of a polynomial that appears as a factor more than once. You can't always see multiple roots on a graph, but when you factor it out, you can. So notice we have an example, y equals x plus 2 squared. So we have x plus 2 times x plus 2. Notice that this is the same thing, and if we were to solve for that, we'd get x equals negative 2, but this is a multiple root because it shows up twice. So this has a multiplicity of 2. Okay, here's our first example, and we want to find all the solutions to the equation x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 is equal to 0. Now, notice I've done the first step already, which is to graph the equation. Now, one thing that you can get from the graph are the rational real zeros pretty quickly. Now, if you notice, this has 3 x-intercepts, so at negative 2, 1, and positive 2, those are my 3 rational roots. So negative 2, positive 2, and positive 1. Okay, so now coming from the fundamental theorem of algebra, since this is a 5th degree root, I know I'm looking for 5 roots, or 5th degree polynomial, I know that I'm looking for 5 roots. I have 3 rational roots, and it looks like the other 2 are going to be imaginary or complex roots since they don't cross the x-axis. So to find these, I need to use synthetic division, which is the second step that I'm going to do. So I'm going to use synthetic division from our 3 roots that I found. So using all the roots that I found, I'm going to synthetically divide this polynomial equation. So I'm going to write down the coefficients of each term. And these terms have to be in descending order, and you can't skip one. So if I was to not have an x to the 4th and it went from x to the 5th minus 3x cubed, we skipped the 4th degree term, and we'd have to place a 0 in its spot. So now I do synthetic division. I'm going to use 1 since 1 is the easiest number to work with over there, and I'm going to go through this. Bring down the first number, multiply the numbers that are on the outside, so 1 times 1, and I'm going to add the 2 that are above each other. So negative 1 plus 1 is 0. Multiply the 2 on the outside, and then add. Multiply, then add. Multiply, then add, and then multiply again. And lastly, we should always get a 0 for our remainder if they are the roots. If we don't get a 0, we're going to have to try something else. Maybe we had a mistake in our math here, and if that's not the case, then one of these is not the roots. So now again, I'm going to go through the division. So bring down the first number, multiply the 2 numbers on the outside, add the 2 together. 2 times 2 is 4, 3 negative 3 plus 4 is 1, 1 times 2 is 2, 0 plus 2 is 2, 2 times 2 is 4, and I get 0 at the end again. And one last time, now I have my negative 2. So bring down the 1 again, multiply the 2 together, and then add. Multiply, add, multiply. And again, I get a remainder of 0, which is good. Now the last step is to find the remaining roots using either the quadratic formula, factoring, or we can use the square root method. And the only time we use the square root method is when my middle term or my b term is 0. And now remember, this is the remainder. This is my constant or c term. The 0 is the coefficient of x for my linear term, so bx term. And then the 1 is my coefficient of my quadratic term, or my ax squared term. So if I'm going to write this quadratic equation out, I would have x squared plus 1 is equal to 0. Now to solve for x, using the square root method, we subtract 1 from both sides. And notice I have x squared, square root method. What do you think? Use the square root. So square root of x squared is x. Now the square root of negative 1 we know is I. But remember, when we take the square root of a number, we need not just the principal root, which is the positive one, but its conjugate as well. So I have a plus or minus I. So that gives me my two complex roots. And then from my earlier findings from the graph, I have plus or minus 2 and 1. And those give me my 5 roots. Okay, so here's an example I want you guys to try at home. So, or at school, wherever you're watching this video at. So I have x to the fourth minus 2x cubed, or I'm sorry, plus 2x cubed is equal to 13x squared minus 10x. Once you finish this, we'll go ahead and pause this, then once you finish it, press play again and I'll show you the answer. Alright, so here's the solution of the problem. First of all, if we look at this, we need to put this equation into standard form. So I did this. You could have done this a little bit differently than me, but what I did is I subtracted 13x squared and added 10x to both sides. Since there are no like terms over here, we just have to write out the 4 terms. So x to the fourth plus 2x cubed minus 3x squared plus 10x equals 0. And that is in standard descending order. So now the next thing that we do is the first thing towards solving the solutions or finding the solutions. Graph it. Well, if you graph it, notice there's 1, 2, 3, 4 points of intersection on the x-axis. And this is a 4th degree polynomial, so knowing the fundamental theorem of algebra, we're going to have 4 intercepts or 4 roots or 4 zeros of the polynomial equation. So there's 1, 2, 3, 4. It intercepts at negative 5, 0, 1, and 2. Those are our 4 roots, and we're done. We don't need to do anything else because that's all we're going to find. Alright, so here's our next example. Notice we have f of x equals 2x cubed plus x squared plus 1. We want to find all the solutions to this equation. So don't let this f of x fool you. It's another fancy way of saying y. It's function notation. But in order to solve this, we want to set that equal to 0. So we have 2x cubed plus x squared plus 1 is equal to 0. Now, remember the first thing we want to do is to graph it and find all our rational roots. Well, notice this graph only crosses at one point at x equals negative 1. So that is our one rational root. So now we're going to use that root to synthetically divide. Now, we write down the coefficients after we make our little L deal. We have 2. Then x squared is the coefficient of that is 1. But notice we go from x squared, we skip the x or the linear term, and we go straight to the constant. So if that happens anywhere, we need to put a placeholder for it. Well, that means the coefficient of that term is 0. So we're going to put a 0 in for our synthetic division, and we're going to finish with a 1. Now, we're going to use the negative 1 that we found over here to synthetically divide. So we bring down the 2 and multiply the two numbers outside. So negative 1 times 2 is negative 2. Add these together. Multiply negative 1 times negative 1. 0 plus 1 is 1. 1 times negative 1 is negative 1. And we get a remainder of 0. So here's your constant, your bx term, and your ax squared. So your a is the 2. Your b is negative 1. And your c is positive 1. Now, if we look at this, we know that our remaining factors are going to be complex since they don't cross the x-intercept. So in order to find a complex solution, we need to use the quadratic formula. So the quadratic formula we know is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now all we have to do is plug in the b's, a's, and c's. So the first term is the opposite of b. Well, my b is negative 1. The opposite of that is a positive 1. Plus or minus the square root of b squared. So we're going to have negative 1 squared minus 4 times a, which is 2, times c, which is 1, all over 2 times a. So 2 times 2. Now, let's go ahead and simplify this. So we have this 1 plus or minus the square root, and underneath we can do this. Negative 1 squared is 1, minus 4 times 2 times 1. That will be 8. So 1 minus 8 will give us a negative 7 all over 4, 2 times 2. Now, we know that the square root of any negative number is an imaginary number. So we can take that negative out. So we have 1 plus or minus, and it's going to create an I out in front. So we have I square roots of, now, positive 7 over 4. If we look to see if we can reduce this, we're not going to be able to. So my two imaginary or complex roots are 1 plus or minus I squared to 7 divided by 4, and my one real rational root is x equals negative 1. And here is the problem that I would like for you guys to try. So we have g of x is equal to x cubed minus 5x squared plus 5x minus 4. Once you're done with this, well, first pause it, then once you're done, go ahead and press play and I'll show you the solution. And here's the solution to the final equation. Notice I have the graph out to the side, and so that's the first thing I want to do after I set g of x equal to 0. And I have one rational root where it crosses at x equals 4. And I set that up and I use that to synthetically divide, and I got 1, negative 1, 1, and the remainder of 0 for my a, b, c. So then I use these three terms to plug into my quadratic formula, simplified it down, 1 plus or minus the square root of negative 3 over 2. The negative came out, and we have an I squared, so 3. And so that's my three solutions or roots. So 4, and then the two complex roots, 1 plus or minus the square root of 3 over 2. So there's my 3. Because it's a cubic function or a third degree function, I know I should have only 3 roots. Thanks for watching. You stay classy, San Diego. Something like that. Bye.